Good evening, ladies and gentlemen. February 12th in the year 1809 witnessed the birth of actually two individuals who would play very significant roles in reshaping the nature of and our understanding of the modern world. One happened to be born in the American state of Kentucky, Abraham Lincoln. And the second one was born in Shropshire, England, Charles Darwin. And curiously, both have found a place on their respective countries' currency. But it is, of course, Charles Darwin whose achievements we're celebrating at Carleton this week. Before I introduce this evening's program, I would like to just take a moment to thank some of the sponsors and collaborators who have made Darwin Week possible, including the British Council, the Royal Society of Canada, the Humanist Association of Ottawa, the Royal Canadian Geographical Society, and CBC Radio. And I'd like to also take the occasion to offer a very special vote of thanks to one of our Carleton faculty members, Professor Christopher Byrne from the Department of Geography and Environmental Studies. Chris had the idea of holding a Darwin Week and started thinking about this about a year ago, and has labored long and hard over the past year to bring this project to glorious fruition. And it seems to me just a shame that his name doesn't appear anywhere on the information that is being handed out this week. So Chris, please stand up and let us thank you. So let me begin this evening by asking the President of the Royal Canadian Geographical Society, Madame Gisèle Jacob, to say a few words. Prior to her retirement from the civil service, Madame Jacob held senior management positions at the Canadian Human Rights Commission and Environment Canada, and she's been President of the RCGS since 2004, an association that's currently, I believe, celebrating its 80th anniversary, so another anniversary to celebrate.
Thank you very much. Good evening, bonsoir. I also want to thank Chris for his work in setting up this week of lectures, and to tell you that we at the Royal Canadian Geographical Society are also very fortunate to be involved with Chris. He's a fellow of the Society, a member of our Board of Governors, and a Vice President of the Society. So you didn't have to twist my arm too much to ask me to say a few words, or to have the Society be one of the sponsors of tonight's evening. We were very pleased to be specifically asked to come to this lecture because the founder of our society, Dr. Charles Camsell, was a geologist. So you can see how well the topic tonight fits with what started off the society 80 years ago. You're right, it is our 80th anniversary. Our mandate at the Geographical Society is to make Canada better known to Canadians and to the world. And we do this mainly through our award-winning magazine, Canadian Geographic, which I'm sure all of you know and love. And we do have copies for you outside for you to pick up on your way out after the lecture. We also have a number of educational outreach programs operating from the school level to the university level. We support expeditions, research, geographic research, and public presentations like the presentation we're going to have this evening. I know that you're all looking forward to Professor Summerfield's presentation as I do, so I will stop here and allow him to speak to us about Darwin's landscape vision. Thank you.
Now, just before I introduce our main speaker, I should advise you of the format that will be used, actually not only for tonight, but for all the events in this series this week. So following the lecture, Professor Michael Church, who is Professor Emeritus in the Department of Geography at the University of British Columbia, will inaugurate a discussion, and that will be followed by an open question period. And you can see there are microphones on each side of the room. Professor Church is a specialist in the areas of fluvial sediment transport and theoretical geomorphology, and is a Fellow of the Royal Society of Canada. He's been a leader in several aspects of physical geography for over 30 years, and is particularly highly regarded for his analysis of experimental field investigations. However, he's with us tonight because of his perspective on the history and philosophy of the surface earth sciences, which is uniquely regarded in Canada and for which many of his colleagues look to him for guidance. And now it gives me great pleasure to introduce this evening's speaker, Professor Michael Summerfield from the University of Edinburgh, incidentally the place where the young Charles Darwin, ostensibly a medical student, first developed his scientific interests in natural history before his father moved him to Cambridge to study theology. Professor Summerfield completed his own studies at Oxford and is widely regarded as one of the United Kingdom's most distinguished geomorphologists. And for those of you who, like me, needed to really understand what that word meant, geomorphology is the study of the form of the surface of the earth. Many people in his field work at small scales, investigating what goes on in the landscape, the scale of a hill slope, or along a reach of a river. But Dr. Summerfield's interest is in the whole landscape, the big picture. And as a result, he appreciates long time scales that are associated with the development of large landscapes. Much of his fieldwork has been in southern Africa, but he's also ventured to Antarctica. And I understand that he's also skilled at the analysis of the landscapes used to produce wine. Seems to me a very useful thing to know about. He has written extensively in the areas of geomorphology and tectonics, including a number of articles published in the journal Nature. It's the intention this week to look beyond pure biology in order to assess the impact of Darwin's work on a broad range of other disciplines. And we know that Darwin was certainly interested in geology, and that interest is reflected in the title of Dr. Summerfield's lecture for us this evening, Darwin's Landscape Vision. Please join me in welcoming Michael Summerfield.
Right, thank you very much for that kind introduction, and I'd certainly like to, I decided to put my jacket, actually, get rid of that, thanks very much. I'd like to add my thanks again, of course, to everybody involved in organising this seminar series. It actually puts my own institution, Edinburgh, somewhat to shame, I think, in terms of it having quite a claim on Darwin in terms of his period there as a student, but it hasn't organised, as far as I'm aware, anything quite as effective as this Darwin Week, notwithstanding necessarily the issue of my own contribution, which might not be quite up to the standard of everything else going on. But Chris, I know, has put an enormous amount of work into organising this. It's also a pleasure for me to be talking to you as somebody coming from Edinburgh, because perhaps not many of you know, there's actually quite a close link between geography at Edinburgh and geography at Carleton. And the source of that link is James Reeford Watson. James Reeford Watson was a student at Edinburgh and then actually came to Canada. And in 1949, he was appointed chief geographer and director of mines and technical surveys, and also in that year founded geography at Carleton University. In 1952, he took up the chair in geography at Carleton. But in 1954, he left to come back to Edinburgh as the chair of geography, a post which he held till 1982. And I very nearly overlapped with him. I actually started in Edinburgh literally 3 months after he finished as as a chair and retired. I did actually meet him on one or two occasions. But his talents weren't just limited, in fact, to geography. He, in 1950, was awarded the Governor General's Award for English language poetry or drama. He was actually some considerable poet, published a number of volumes. I've not actually looked at them personally, but I understand their contents in some cases was somewhat, shall we say, racy. But his poetry was certainly acknowledged as being reflected in that award given to him in this country. So, Darwin's landscape vision. One always worries, I think, about a title one might give to a talk because titles can sometimes convey very clearly to a potential audience what the speaker's going to talk about. In other cases, it's perhaps a little more obscure. By Darwin's landscape vision, what I'm really going to focus in on is the way Darwin had a remarkable ability to look at something, but to see something in that look that other people hadn't seen. And indeed, in terms of looking at the landscape, to see things that weren't actually there, but that he envisaged had been there at some time in the past. I think this idea of different people looking at the same thing but seeing something different is a very important characteristic of a talented scientist, or indeed anybody with talented analytical skills. And there's actually a little story I think is relevant to this, which also has an Edinburgh link, that of Sir Arthur Conan Doyle, the inventor of the character of Sherlock Holmes. And in fact, Conan Doyle wrote one of his lesser-known short stories, involves a camping trip that Holmes and Watson were on. And Holmes and Watson are sort of lying back, looking upwards, and Holmes says to Watson, well, Watson, what do you make of all this? And so Watson thinks, and then he says, well, astronomically, I can see thousands of stars, and I know there are thousands of more that I cannot see. Meteorologically, I can see it's a clear night. And chronologically, I can tell from the position of the constellations that it's about 3 o'clock in the morning. And then Watson says to Holmes, well, Holmes, what do you make of it? So Holmes says, I wonder who stole the tent. So this kind of different take is, I think, something important and an ability, a sort of Holmesian ability, which I think Darwin had. Now, as we all know, Darwin is, of course, celebrated this year for really his contribution to biology. In fact, it's been argued he's really the founder of modern biology through the development of his theory of evolution by natural selection, and indeed through, in that stage in the mid-19th century, of making the idea of evolution widely accepted. And these kind of images I put on the screen here, the spine of a first edition of The Origin of Species, the one that's held at Cambridge, and these various images from the Galapagos Islands and the various birds and animals that he observed there. That's the kind of picture we have of Darwin. But there is another Darwin, and a Darwin which in the early part of his career was the dominant Darwin, and this wasn't somebody who was really a biologist at that stage. But this early Darwin, I think, not only did work which in itself was very innovative and important, but also, I believe, in the way he did that work, it served as an important stimulus and a framework by which he then tackled the issue of organic evolution. And that's really what I want to do this evening. I want to really look at the way Darwin looked at landscapes and the way he looked at landscapes and examine how that contributed to a broader range of his ideas and his methodology. Let's just begin with this quotation, which really summarizes up what I mean by landscape vision. In fact, Darwin wasn't very effective by and large. There's one or two notable exceptions with the use of diagrammatically or pictorially representing landscapes, but he painted beautiful landscapes in the words that he used. He says, I am tempted to give one other case, the well-known one of the denudation of the Weald. It is an admirable lesson to stand on the North Downs and to look at the distant South Downs. For remembering that at no great distance to the west, the northern and southern escarpments meet and close, one could safely picture to oneself the great dome of rock which must have covered up the Weald within so limited a period as since the latter part of the chalk formation. Now, we're going to come back to this quote later on, but this is really what I mean by Darwin's landscape vision. What he's talking about here is an area in Kent, in southeast of England, in fact, the area where he was living at the time he wrote this, at Down House. And what he's doing is he's imagining a structure which is actually technically called an eroded anticline, that you have had up-domed rock, the central part of which has been eroded away. And what he's trying to do is picture see the landscape it is now and picture what it must have been before. And in this context, as we'll see, draw some rather important conclusions about what it was like before and what it's like now and what implications that had, in this case, for the period of time that had elapsed. So I'm going to first of all just convince you that Darwin was actually a very active geologist, and geology actually dominated his work for the early part of his career, really the first third of his career. I'll look briefly at some of the influences, particularly those early influences he had at Edinburgh and at Cambridge as a student, but also during the Beagle Voyage and immediately afterwards. We'll then just look briefly at the voyage, because I think it's important for us to see the landscapes that Darwin saw on that trip. Then to look at how he tackled landscapes, and this work was already beginning on the Beagle Voyage and was developed very significantly immediately he returned, and then see how this work on landscapes wasn't just done in some ad hoc manner, but was really part of a broader plan to develop a system of the Earth, an understanding of how the Earth's surface related, in particular, to the behavior and the nature of the Earth's interior. I'll also be talking about another important aspect of this work on landscapes, which is the way he used it to try and establish that long periods of time had existed in Earth history, a very important thing, of course, in terms of his ideas about organic evolution. Then look at some of the methodological aspects of how he tackled landscapes and see, I think, some important parallels, and this has been pointed out by a number of people before, important parallels between the methodology applied there and the methodology then, in fact, applied to developing the arguments about evolution by natural selection. And then talk about something I've actually pinched slightly, a kind of phrasing that tomorrow night's speaker might use about research in its place, about I think something one could argue about Darwin's decision he took in 1838 to get married and the influence that actually had on rather demolishing his geological career, but actually then spawning a much more active career in looking at evolution and looking at things biological. So quickly, Darwin as a geologist. Well, one week we could perhaps do this is just simply look at what Darwin was publishing in his books. What I've done here is listed essentially in a chronological order all the books that Darwin published, and some of the titles have been shortened, abbreviated. He changed the titles of things, but this gives you a good idea, and it's color-coded. So basically, the red titles are ones which are essentially wholly geological works. The ones that are in a sort of a pinky colour are works which have some significant geology in them, although they're not necessarily primarily geological. And the ones that are sort of greeny colour are ones that are on other topics, either biological or psychological topics. And you can see, particularly in the earlier publications, it's really dominated by these geological works. We can also perhaps try and convince you of the importance of geology by looking at the papers Darwin produced. Now, a simple count of papers is a bit of an unsophisticated way of doing this, because many of the papers Darwin wrote were really very short notes, and so it doesn't give a total idea of the sort of length of these contributions and how substantive they were. But we can clearly see that in the early period, 1835, when he was first sending notes back from actually the Beagle Voyage, which were notes which were then read out at the Geological Society, until the time he moved to Down House, that period is really rather dominated by geological work, as indeed is the immediate period after he established himself at Down House, when he was finishing writing up the work from the Beagle Voyage and writing up some other work he'd been doing, which was the geological theme. And then it does fade out, but it never entirely disappears. Now, another way we could look at Darwin's work is to look at what he was doing on the Beagle Voyage. The Beagle Voyage was this nearly 5 years of substantial amounts of field observation. Whenever he could, Darwin got off the Beagle because he used to get dreadfully seasick, and whilst all the surveying operations were being done, he would be on land making excursions, making observations. And it's possible by looking at the notes he made on this voyage, and these are the notes which are held in the Cambridge archive, about 800 pages of those notes consist of a sort of a journal narrative, what he was doing, who he was seeing, where he was travelling. 400 pages of that material are zoological notes. There's actually nothing really specifically botanical, which is rather interesting given his interest in things botanical later on in his career. But 1,400 pages of these notes were geological. His interests were essentially geological during the Beagle Voyage. Perhaps not the familiar image we're used to in terms of sort of the retrospective view that we see when we look at the importance of his biological contribution later on. Another indication of his interest in things geological was the fact that he actually was elected to the Geological Society immediately he got back from the voyage. It actually been mooted to him, I think, by Sedgwick before he went on the voyage, Sedgwick, a geology professor at Cambridge, that he might become a member, but he did very rapidly, and in fact, he served as secretary from 1838 to 1841. The secretary's job in them was an onerous task, taking 2 or 3 days a week of work. So this was serious business as far as Darwin was concerned. We also see, I think, something of the importance he attached to geology even later on, when in 1844, when he'd completed his extended essay describing how he thought his mechanism of natural selection would operate in terms of producing organic evolution. He was concerned that this contribution would, if he were to die unexpectedly, be published. So he wrote a letter to his wife, Emma, explaining that she should arrange for an editor to be appointed to oversee this work. And it's interesting that he should say he prefers Charles Lyell to do this, and that if it couldn't be him, it was important, or in fact must be, a geologist as well as a naturalist to do this work. And finally, there's the rather sort of mundane point that in all the stuff that Darwin published, as far as it's known, that the only time he actually described himself as a specific kind of scientist, he described himself as a geologist, rather strangely, in the Gardener's Chronicle and Agricultural Gazette issue for the 26th of May, 1855. Just a tiny little note about the survival of seeds in salt water. This was all to do with ideas of whether things could travel from one continent to another, all part of the kind of geological agenda that Darwin had, even at that stage. Now, of course, there have been a number of people before that have looked at Darwin's geological contribution. In fact, exactly 100 years ago, well, nearly exactly, and I think it was in June the event occurred, they had the equivalent of what is going to happen this year in Cambridge. They had a 100th anniversary of his birth and a 50th anniversary of the publication Origin of Species celebration at Cambridge. And at that event, Archibald Geikie, who was then a very noted geologist, who was then president of the Royal Society, he gave the main lecture, the Reed Lecture, as it was called, and its title was Darwin as Geologist. It was justified by Geikie in terms of, well, everybody knew about his biological contribution, so let's hear about something slightly different. But nonetheless, the geological work obviously had to be of sufficient importance for that lecture to be appropriate. And a number of people have highlighted Darwin's contributions to geology, historians of science such as Martin Rudwick and Sandra Herbert, whose book, I understand, is available for you to see and, in fact, buy outside the lecture room this evening. And also David Stoddart, a geographer who spent many years in the study of modern coral reefs and coral atolls, who also was a great expert and had a great interest in Darwin's work. Just very briefly, before we sort of look at how Darwin approached landscape, let's just look at some of the influences he experienced. First, we've got on the left Robert Jameson. He was a professor of natural history at Edinburgh when Darwin was there. Darwin there went ostensibly to learn medicine, but he really didn't take to that idea. Operations being carried out on children without anaesthetic wasn't the sort of thing he found he could readily accommodate, and he tended to go off. And I think this shows actually not just an average sort of student, which kind of Darwin tends to create the impression of in some of what he wrote about himself. But this indicates a very interested young mind. And he went to Jameson's lectures, and he writes that he found them very tedious, but those were the zoological ones as well as the geological ones. And in Janet Brown, in her fantastic biography of Darwin, actually talks about Darwin having made desultory sort of notes in the textbook that Jameson had produced on geology. But in fact, I think Sandra Herbert calculates about 2,500 words of annotation in that book. So clearly, if he found the lectures boring, he still found the subject of some interest. Henslow, of course, was a great influence on him in Cambridge, where again, although he was supposedly training for the ministry, he seems to have spent most of his time with developing his natural history interests and also his geological interests. And Adam Sedgwick, the professor of geology, who, again, as a student, he got to know well enough to be invited to join Sedgwick on a week's excursion to North Wales, where Sedgwick had been working on the ancient Cambrian rocks in that locality. And Darwin went along as a sort of a geological training trip, a field mapping trip. So this really meant that by the time that he got the invitation, which immediately occurred, he actually got this immediately, he got back from this trip to North Wales, the invitation to go on the Beagle Voyage, which had been organised through Henslow as an intermediary. Darwin was much more trained as a geologist than anything else, so it's not really surprising he did so much geological work on the voyage. But there are also, if you like, more methodological influences that Darwin experienced particularly through things he read. John Herschel's book on what we call natural philosophy, really on scientific method, had a great impact on him, and he read this whilst he was at Cambridge. And he was also greatly influenced by Lyell, I think, who was master at Trinity College at Cambridge, who also had a particular take on scientific methodology. I think really the thing he learned from Herschel was the importance of both inductive and deductive approaches to understanding the world, whereas the message he got from Lyell was something which Lyell gave the phrase consilience of inductions to. I'll be kind of using a more sort of lay term as the use of corroborative evidence, the idea of using a set of independent lines of evidence to see whether they're compatible with an idea that you might have. And we'll see that's exactly the approach that Darwin took in looking at the landscape. And then finally, somebody that Darwin, I think, always said influenced him more than anybody else was Charles Lyell. He was actually given a copy of Lyell's first volume of the Principles of Geology by Captain Fitzroy, who we'll, of course, come to in a second on the Beagle Voyage, as the voyage started. And he acquired the other two volumes as the voyage proceeded. And Lyell was important because Lyell, at this stage in 1830, proposed a way of looking at the Earth which very much emphasized what you could learn about the Earth from processes you could actually see operating at the present, rather than speculating about things that might have happened in the distant past, or indeed just speculating about what might be going on in the Earth's interior. So there was the methodological component to what Lyell proposed. But there are also some other kind of empirical observations Lyell made, or in fact assumptions. He tended to emphasize the idea that large changes could be accumulated by a whole load of small increments, and so you could get quite significant changes in the Earth's form if you allowed sufficient period of time to occur, even with a rather slowly acting process. And then rather more mystically almost, Lyell had this idea of the Earth being in some long-term steady state. This was something he changed his mind about later on in his career, but he had an idea of both a temporal and a spatial steady state. He thought the Earth had gone through cycles of climatic changes and indeed went through cycles of organic change as well. And rather notoriously, in the early editions of Principles of Geology, he talked about the iguanodon at some time in the future wandering again in the forests of the Weald of Kent, the Weald of Kent where iguanodon fossils had first been identified by dug up by Gideon Mantell, in fact. But he also had this sense of a steady state on a global basis. So if some areas of the Earth were being uplifted, he sort of assumed that other areas must be subsiding. Now, that idea of compensation between uplift in some places and subsidence in other places was a very important idea that Darwin took with him and applied it, as we'll see in a minute, when he looked at some of the important landscape features he saw on the voyage of the Beagle. So very briefly, I think most people are familiar with the voyage in outline. The ship left Plymouth, in fact Dartmouth, the port at Plymouth, and headed down to the east coast of Brazil. It spent a long time on the east coast of Brazil. The purpose of the mission was very much to do with British imperialism and colonial expansion and future trade. It was very important to have coastlines accurately mapped, and the mapping for the southern part of South America wasn't particularly good. So Robert Fitzroy, at this stage, a very youthful 26 only, was captain of the ship. And basically the story goes that he thought it would be rather good to have a gentleman companion, and that's how Darwin got to get on the ship. He wasn't there as any official naturalist, but it was sort of understood that he would carry out his own kind of naturalist-type work. Fitzroy was also very interested in natural history and indeed in geology. So they spent around 27 months actually on the east coast of ship going backwards and forwards, but gave Darwin quite a lot of opportunity to be involved in expeditions inland. Eventually it went round through the Magellan Straits and then onto the west coast of South America, spent another 15 months there. Overall, the trip was 57 months, but they returned on the last leg across the Pacific to New Zealand, then Australia, then across the Indian Ocean. They had to come back to the east coast of Brazil in order to have the check on longitude. They were taking these chronometers with them to make sure they had their measurements accurate, and then they returned to Britain. Now, this is a quick sweep around the landscapes that Darwin was seen on that trip. The Santa Cruz Valley, where Darwin went on an expedition, I think also with Captain Fitzroy, over a number of days, hauling a boat up this river some considerable distance and observing a very interesting flat landscape surfaces in this location. Then later on going down into the glaciated terrain of Tierra del Fuego, and then along the west coast of Chile at what had already been noted as an interesting site of these terraces, flat-like forms separated by steeper slopes, which had been observed by an earlier British captain, Captain Hall, and were known actually to Charles Lyell and were commented upon in the third volume, I think, of the Principles of Geology. Then from Chile, of course, to Galapagos Islands, which we all associate, of course, with his observation of the birds and animals there, but also he made significant geological observations. And then on across the Pacific to Tahiti, then on to the Bay of Islands in New Zealand, across to Sydney and an excursion into the Blue Mountains inland of Sydney, and then via the Cocos-Keeling Islands in the eastern part of the Indian Ocean, and then, in fact, he called in on Cape of Good Hope as well before returning home. So landscapes then, so what was he looking at here? Now, the term geology, and the time Lyell was writing the Principles of Geology, encompass really two things which really at the end of the 19th century and into the 20th century became rather more separated. Geology, strictly speaking, is concerned with materials, it's concerned with rocks. But there's another aspect of the Earth, which of course is the actual forms shaped on the surface, the landforms. And the terms geology and geomorphology distinguish between, to some extent, those two terms. So the term geology in this earlier period would have encompassed both those ideas. But my feeling is that a lot of Darwin's observations were really rather more focused on the geomorphology than they were on the geology. True, he collected many rock samples which were sent back, and many of those are retained in the Sedgwick Museum in Cambridge to this day. But his observations of form, I think, were very important. And those are illustrated by going back to this site in Chile, which Darwin visited and observed and drew quite detailed diagrams. He recorded the sediments, the rock types he observed, but he paid a lot of attention to the relative heights of these various flat surfaces, which were being measured in many cases by aneroid barometer, by the decrease in pressure with elevation. So form is very important to Darwin, and it becomes even more important when he starts to address the issue of coral reefs. Now, coral reefs he had known from things he would have read geologically, even before he saw one, were quite a big problem in geology. This isn't a view, of course, Darwin would have had. This is a view from the space shuttle of some coral reefs in the Pacific Ocean. And coral reefs are essentially coral which is just a few meters or very close to the sea surface, in some cases surrounding islands, in other cases forming just a ring of coral with no actual island in the middle, but just a shallow lagoon. And these sort of ring-like structures were mostly thought by most people, certainly by Lyell, to simply exist on a substrate of a volcano just below the surface. So their idea, volcanoes rose from the seabed, and you just got the ring of coral growing around the crater rim. But Darwin had a rather different idea about this, because Darwin had noticed that you get situations where you get a volcano with a fringing reef, so a reef close to the volcano. In other cases, you get a volcano where the reef is much further away. There's a bigger area of water between the coral and the volcano, and that is termed a barrier reef. And then you've got these forms with no volcano at all, just the coral, a form called either a lagoon island is the term he tended to use, which we now, in the modern term, call an atoll. Very interesting, this comment that he made in an essay he wrote actually on the Beagle whilst traveling across the Pacific. He says, this is when he was actually in Tahiti, and he was standing high up on Tahiti overlooking the adjacent island of Moorea. And he says, I was forcibly struck with this opinion. The mountains abruptly rise out of a glassy lake, which is separated on all sides by a narrow, defined line of breakers from the open sea. Remove the central group of mountains, and there remains a lagoon island. So what he was doing here, he was having a landscape vision. He was envisaging this type of landscape, but taking away the volcano, and then you'd end up with a lagoon island or an atoll. And this then gave rise to his theory about how coral atolls formed. So what he suggested is that, yes, you had initially a fringing reef of coral growing around a volcano. Corals are organisms, in fact, a symbiotic relation between photosynthetic algae and the coral-forming structure. And the idea was that if you imagine the volcano would start to subside, the coral, if they were able to grow up quickly enough, would just keep growing up close to the water surface. Eventually, if the volcano kept subsiding, it would go below sea level, and you would end up with a mound of coral based on that volcanic substrate, not just rimming the crater rim. And in theory, the volcano could keep on sinking and sinking and sinking, the coral could keep growing up. So that was his suggestion, and it was developed in one of his early papers he wrote when he came back, based on the manuscript he wrote actually when he was in the Pacific. But what he was doing there was really transforming space into time. He was seeing islands in different places, but envisaging them as being what you would see in one place if you could stay there long enough, over, as we would now know, actually millions of years. So this was a powerful landscape vision of seeing things that weren't there, but really envisaging things that weren't actually there. And in his autobiography, he specifically made a comment about the development of this theory. What he says was, no other work of mine was begun in so deductive a spirit as this, for the whole theory was thought out on the west coast of South America before I had seen a true coral reef. And we actually know that from some notes he made, that he did truly actually develop the bones of this theory before he'd actually got into the Pacific. I had therefore only to verify and extend my views by a careful examination of living reefs. But it should be observed that I had, during the 2 previous years, been incessantly attending to the effects on the shores of South America of the intermittent elevation of the land, together with denudation and the deposition of sediment. This necessarily led me to reflect much on the effects of subsidence, and it was easy to replace in imagination, again, vision, in imagination, the continued deposition of sediment by the upward growth of corals. To do this was to form my theory of the formation of barrier reefs and atolls. So what he was doing there, he was actually taking this idea from Lyell of a lot of evidence he'd seen of uplift in the Andes from those various terraces, and we'll see some pictures of that in a minute, and also the presence of marine shells at high elevation. So there's plenty of evidence of uplift in South America, reinforced somewhat by an earthquake he experienced when the ship was at Valdivia, and later they went up to Concepcion, that was the epicenter of the earthquake, and Darwin was really rather startled by the amount of damage that had been produced, but he observed that the shorelines had actually moved during this earthquake event. So a powerful evidence of uplift, and then the idea, well, if the Andes are subjected to uplift, then areas of the Pacific Ocean potentially are subject to subsidence. If you have subsidence, then you get the application of his theory of coral reef formation. But he didn't just leave it there. What he then did was thought, what sort of evidence would corroborate this idea? Well, one sort of evidence he used, which is probably one of the more remarkable maps that's ever been produced, and also rather strangely the only time that Darwin ever really used this strategy to support his ideas. When he got back from the Beagle Voyage, and probably even during it, because there were a lot of nautical charts on the Beagle, he actually plotted out islands which just had fringing reefs, but no reefs well away from the island or atolls. Those are the chains in red, but all the ones in blue are where there was strong evidence of subsidence, in that you had coral atolls or you had barrier reefs being formed. Now, the importance here was the nature of the spatial distribution. If this theory of coral just forming on the crater rims of volcanoes was true, then you could have all these things spotted all over the place. You wouldn't expect them to group together. But the power of this map is it shows zones of evidence of subsidence. So that's exactly what you expect. If it was due to the seafloor subsiding, this would occur over a broad area, so you'd get broad areas of the formation of the sequence from fringing reefs to barrier reefs to atolls. So an extremely powerful use of geographical distribution to support his idea. What's more, he also observed, and he got actually Fitzroy to make soundings in the Cocos-Keeling Islands to check this out. If the coral was just sitting on the volcano, as you went offshore, you then pick up the slope of the volcano. But what they found is that you got very, very steep sides to the coral, which went down and down and down. So they couldn't really be sitting on the volcano. You didn't have the volcanic slope, you had the coral slope. So again, evidence which supported his idea. And this is illustrated in any coral reef by the deep blue water you see. This is just a shot I took once taken off in the island of Aitutaki in the Cook Islands group. He also, when he came back, investigated evidence of the rate at which corals could grow. And it seemed fairly clear that any rate of subsidence was unlikely to outpace the rate of coral growth in warm tropical waters where corals lived. Now, this work on coral atolls is sometimes presented as, oh, well, he was interested in coral atoll formation. Indeed, sometimes it's presented simply as an extension of his work on biology. Just the other week, there was a David Attenborough big program on BBC television in Britain about Darwin, and at the end he just said, oh, and he studied other life forms as well, such as corals. But he didn't study these things because they're interested in life forms. He studied them because they were a part of his developing idea of a system of the earth, of trying to develop a general way of looking at areas of uplift, evidence of uplift and subsidence, to create a theory, a general theory of the earth. And this is really what he did when he came back. He was going to originally write one large volume on the geology of the voyage of the Beagle. In the end, it ended up as 3 separate volumes. And as we read through these, they're all part of a scheme to develop this system of the earth, to look at the fundamental mechanisms underlying the formation of the Earth's topography by trying to work out what the patterns of uplift and subsidence were on the surface. So it's always this emphasis on uplift and subsidence. He was of the view, which was supported by Lyell and many other people at the time, that marine denudation, wave action, was a dominant way in which this erosion occurred. That idea has now been largely revised, except in some near-coastal areas, to one of fluvial denudation. But he was also concerned in the way the rates of landscape change and the idea that incremental change could produce large modifications of the landscape over long periods of time. Very quickly, just show you some of the pages. This is from the South American volume. And where he does use diagrams, they always are diagrams of these surfaces which are describing the effects of uplift. And even in his notebooks, this is a little sketch he made of the island of St. Helena, where what he's doing is showing that where the trade winds are coming in, bringing wave action in, the shape of the island has been modified by this. So they're again giving evidence of changes of elevation and the efficacy of these erosional processes. And so this is most dramatically demonstrated in this location in Chile, which is by the coast, and these are indeed marine platforms. And to Darwin were very clear illustrations of this successive uplift occurring. Now, this idea of using the surfaces to record uplift and subsidence was one that really took Darwin over. And it actually led to probably his, well, he himself described it as a dreadful blunder in terms of work he did when he got back from the voyage. When he got back from the Beagle Voyage, he took, for him, actually a rather major expedition up to the west of Scotland into a valley called Glenroy to examine features which were known as the parallel roads of Glenroy. And you can see them here. There are these little flat line areas along the slope. There's 3 or 4 of them can be identified. These features had been known in the early 19th century and written about. And in fact, an early idea was that they were formed by a lake shoreline, that some barrier had produced a lake in the valley and the shoreline of the lake had produced these surfaces and the barrier had changed the level of the water at different times. And in fact, rather ironically, the terraces in Chile had actually been interpreted with respect to these shorelines in Glenroy. But it was even more difficult to envisage what barrier could form a lake along that shoreline in Chile. So when Darwin came back and he looked at these features, and although he couldn't find any evidence of marine fossils which should be there if these were terraces produced by the sea, he still ended up arguing that these were evidence of uplift because they were marine shorelines. So this was just after he got back from the voyage, a major paper in the Philosophical Transactions of the Royal Society in 1839. But unfortunately, just then was coming about a new development in geology, the acknowledgement of how extensive glaciation had been in the past. And no sooner was the ink dried on this paper than the idea that there was a ready-made barrier that could actually have produced a lake in this situation, and that barrier was, of course, ice. So this was rather illustrating that relying on just this evidence from form alone was a problem. And in fact, he really broke with the tradition of using several lines of independent evidence in this Glenroy study, and he in fact came unstuck with it. So to summarize then Darwin's sort of this model system of the Earth, that he sees the world being consisting of zones of uplift and subsidence broadly in linear lines, and this came both from Lyell's work, but also he was an avid reader of Humboldt, and Humboldt had speculated about the sinking down of Western Asia coinciding with the elevation of Central Asia and the Himalayas. He also, because of the sort of wavelength of these deformations, concluded, although he never gave a very precise number, 20 miles is about as precise as he got, he concluded that the Earth was covered by a thin crust with fluid motion beneath. And this movement to this fluid motion was what explained the topography. So you could use the topography to gain insights to the interior of the Earth. And indeed, he picked up a point that Herschel suggested, that if you get quite a lot of erosion near the coasts along continents, then this transfer of mass in that erosion could actually also cause flexing of the crust, something we would now call flexural isostasy. I just want to go now quickly as we move on towards the end of what I want to say, the importance of landform in the lapse of time. In The Origin of Species, Darwin says this. He says, but the amount of denudation which the strata have in many places suffered, independently of the rate of accumulation of the degraded matter, probably offers the best evidence of the lapse of time. So what he's saying is, rather than the accumulation of sediments in different rock units giving you a sense of time, he really thought that the form of the land surface was the most compelling evidence of how much time had elapsed in terms of geological timescales. And he says, I remember having been much struck with evidence of denudation when viewing volcanic islands which have been worn by the waves and pared all round into perpendicular cliffs of 1,000 or 2,000 feet in height. For the gentle slope of the lava streams, due to their formerly liquid state, showed at a glance how far the hard, rocky beds had once extended into the open ocean. So he's using landforms to get an idea of the lapse of time that was so important to his agenda of establishing a long period of time in which organic evolution could occur. And this is just a slide which actually illustrates that effect, not any islands that Darwin visited, but there's the idea of wave action paring away one side of an island to give you a sense of how it had changed from its original form. And then we go back to that first quote I had about him standing on the Weald and looking at these escarpments. That quote comes from The Origin of Species. Again, he's using his landscape vision to document this sense of a lapse of time. Now, this is the penultimate point I want to make is about methodology. Clearly, Darwin was much influenced by Lyell's methodological approach to looking at the Earth. And if we look at the first page of the chapter he wrote on geology in Sir John Herschel's manual that he produced basically for naval officers traveling around the world on different areas of science, Darwin talks very much there about how useful it is you can observe present processes and make various inferences about how they might have been effective over longer periods of time. But there's certainly another aspect to Darwin's methodology, I think, and that's illustrated rather compellingly in the first essay he produced on natural selection. This was the one short essay he produced in 1842, only discovered after actually the death of Emma Darwin under the stairs at Down House. And the very last two lines of this essay say the following: "We do not know that species are immutable. On the contrary, what arguments against this theory except our not perceiving every step, like the erosion of valleys?" So what he's saying there is that we can't argue that species don't change just because we can't see them changing, because there are other things we know change which we can't see actually change in front of our eyes, such as when valleys are eroded. So even here he's making this parallel between looking evidence of lapse of time through landscapes and how landscapes can change imperceptibly over time, and how therefore he's arguing why can't species do that as well. But we see some really quite compelling similarities between the structure he had for the arguments of coral reefs and the arguments he actually used for his theory of natural selection. With the coral reef theory, what he makes is some observations and some assumptions. He says coral grows in shallow water. Volcanoes subside in some areas of the ocean. Coral growth upward can match the rate of subsidence. You put those three things together. If those three things are true, inevitably coral atolls will form. You will get a sequence of fringing reefs, barrier reefs, and atolls, and there will be intermediate forms. Natural selection. Offspring resemble parents, but vary to some extent. More offspring produced than can survive, the Malthusian insight. Those that survive and reproduce will be those selected with respect to competition for resources. If each of those statements is true, then particular organic forms will arise, and you'll get transitional forms predicted. So the structure, again, this has been pointed out by philosophers of science, historians of science before, a lot of similarity between the way those two arguments are structured, but of course the Coral Island argument came first. Also similarities in the way that these ideas were then evaluated. The coral reef theory, a series of independent sources of evidence to try and see whether that theory works. With organic evolution, and this has been recently re-emphasized by Michael Ruse in his book, The Darwinian Discontents, using different lines of evidence, paleontology, geographical distribution, classification, morphology, embryology, all seeing whether they're consistent with the central idea of organic evolution. One further aspect of methodology comes from what happened to Darwin's idea of a thin crust. In the 1840s, Hopkins, who was a mathematician but had geological interest based at Cambridge, tried to pose the question about how you could tell how thick the crust was by examining the pressure that was exerted on the crust of the Earth and its fluid interior by the sun, the moon, and the centrifugal force of the Earth's rotation. So he said, well, those three things are going on. We could work out the mathematics. So after a whole load of differential equations, he came to the conclusion, upon the whole, we may venture to assert that the minimum thickness of the crust of the globe, which can be deemed consistent with the observed amount of precession, cannot be less than 1/4 or 1/5 of the Earth's radius, i.e. 1,000 miles. That was sufficient to prevent really Darwin ever addressing that issue again. He never attacked Darwin directly in print, but Darwin's view was based on observations of what he'd seen in the field. Hopkins' view was based on mathematical deductions from a number of assumptions. Of course, our current view is the crust, or if you might say the rigid lithosphere, is much, much closer to Darwin's estimate than it is, of course, to Hopkins. Hopkins actually did a rather cute review of the origins, and in Darwin, on reading this, wrote to Asa Gray, and this sort of reflects the two different approaches. He says, I believe that Hopkins is so much opposed to the origins, that is, because his course of study has never led him to reflect much on such subjects as geographical distribution, classification, homologies, etc., etc. Hopkins didn't see the need to look at a whole series of independent lines of evidence to evaluate whether his theory was correct. Two rather different methodological approaches there. Finally, on methodology, something which is wholly speculative, which came out of a series I gave at Durham a couple of years ago. One of the people giving a talk who came to my talk, which I gave on Darwin's geomorphology, was a psychologist. And in showing the different sorts of Darwin's work, I put this image up from the Expression of the Emotions to refer to Darwin's psychological work. And this was, of course, the pioneering use of heliotype photographs, the first book ever to use these to represent people's expressions. Of course, Darwin very much attempted to use the landforms, the surface of the Earth, as an expression of what the interior of the Earth was like. Is it too much of a leap to say what he was also doing in his psychological work here was using expressions of people, the morphology, the landscape of people's faces, to say something about the interior of the mind? Any psychologist here will no doubt be horrified by any suggestion there's any parallels there, but it might be just something to throw out. Finally, why did Darwin sort of give up this geological agenda? Why did he then move into really almost wholly biological work? Well, of course, in 1842, he moved to Down House, but that really arose from an earlier decision he made, which was what you might say a lifestyle decision. In 1838, he was contemplating whether to get married or not, whether to ask his cousin Emma to marry him. And being very a methodical person, he made a list of the advantages of marrying and the disadvantages of marrying. And in this list of if not marry, he says, if not marry, travel, Europe, yes, America. If I travel, it must be exclusively geological, United States, Mexico. He then puts a caveat, depend upon health and vigor and how far I become zoological. So at this stage, he's actually thinking about extending his geological work. But as we know, in the end, he decides to get married. Then it becomes a question of where does he live. He thinks about London, but he says, I've so much more pleasure in direct observation that I could not go on as Lyell does, correcting and adding up new information to old train. Lyell, having written the principle, spent most of the rest of his life producing new versions of it and other variants of it. And I do not see what line can be followed by man tied down to London. In country, experiment and observations on lower animals, more space. So what he did is he set himself up in the country at Down House, and he adapted his research interests to that environment. He could continue his theoretical work, of course, speculating about species, but he then started to work on things that could be sent to him. He spent 8 years looking at barnacles. Barnacles could be posted to him. You can't post landscapes. He could no longer work on landscapes because he would have to have gone out and visited them. He shifted to studying plant adaptations and looking at psychological questions, including observing his own children. So his understanding of the landscape, and in particular his work on geomorphology, was really rather limited to the back garden. And in fact, in the end, he returned to worms. Now, he'd written a paper early on about earthworms and the role they played in churning over the soil and creating soil. And his vast book was The Formation of Vegetable Mold Through the Action of Worms. An interesting book. It's partly psychology. It looks at worm behavior. It's partly biological. It looks at worms as organisms. But it also looks at worms as agents of surface processes, documented at down the amount of material being moved in ounces, careful measurements, comparing it with data he'd managed to collect from somebody else. Who on earth else was measuring the weight of worm casts? I don't know, but he's got some other observations in here. And so he ends up adapting his scientific agenda to where he was located. And of course, he did develop ill health, which may have clearly affected a geological career later on in any case. So I end there, and just to say that Darwin, I think, was very attached to the idea of looking at landscapes. He records in his autobiography, when he's finished talking about how poetry used to interest him, but then he got much less interested later in his life. He said, in connection with pleasure from poetry, I may add that in 1822, a vivid delight in scenery was first awakened in my mind during a riding tour on the borders of Wales, and this has lasted longer than any other aesthetic pleasure. Thank you very much for listening.